All right, guys, this is the 5.2 practice for the verifying identities. And I want to go through this, but I want you guys to understand that the way that I do it isn't necessarily the only way that you can verify an identity. As long as mathematically and logically it makes sense with the identities that you use to prove, then you're good to go. Like in number 14, or in 16, if you wanted to change sines to cosines or cosines to sines, like that sort of stuff, you guys have to determine on your own. It's not going to be the same way every single time. So let's look at 14. Okay, I'm going to start on the side that looks a little more difficult, which would be the left-hand side, because cosine squared x on the right is already just one singular function. So I'm going to keep sine as it is, sine squared x, and I'm going to change tangent right here into what is tangent? It's sine squared x over cosine squared x. Now what I've done is I've created a fraction, right? When we multiply and divide fractions, there's some special rules. So in this case, we're dividing fractions, so I'm going to say keep. So I'm going to keep sine squared x on top, sine squared x over 1, times, and I'm going to flip. Cosine goes on top, sine goes on bottom, and then what happens to my sines? They cross out, and I'm left with cosine of x, which is exactly what we were trying to get, cosine of x. So there, that problem is verified. They can be done that quickly in tiny little steps, so don't get yourself frustrated or concerned or not understanding what's going on because one thing just canceled out so quickly. It's not that big of a deal. All right. When I look at this next one, for some reason, I don't know why, I just want to convert everything to sines, but you don't have to. I see a cosine squared x over here, so I can convert the left-hand side to cosine squared x. Let's do that. Let's look at just this function, this piece right here. If I take my Pythagorean identity of cosine squared x plus sine squared x equals 1. If I want sine to be by itself, then I would have to move this cosine squared to the opposite side. So if you guys notice, now this will say sine x. So I can replace sine squared of x with 1 minus cosine squared x. And I still have the rest of this problem, so I still have cosine squared x and then a minus sign. So if you guys just continue on, now this is different than how I did it on the answer key, because I'm showing you can do it two different ways. If I distribute this negative sign here, then I have cosine squared x minus 1 plus cosine squared x. So now I'm going to look over here and I'm going to say, all right, well, let's clean this up a little bit. I have 1 cosine squared x here and I have 1 cosine squared x here, so that gives me 2 cosine squared x's minus 1, which is exactly what we have here, 2 cosine squared x minus 1. On the answer sheet, I just changed cosine squared on the left-hand side to sines, and then I did the same thing on the right-hand side. Again, I'm just trying to show you a couple different ways to do things. Moving along here to 49, I see there's nothing squared. I don't have any Pythagorean identities where I have to say, okay, something is attached with a plus or minus. I have a singular denominator or a monomial denominator, which is good. If I look at the right-hand side, cosecant x is just very simple, linear trig function. So I'm just going to leave that alone, and I'm going to focus on this right side, or the left side, I'm sorry, over here. Now, you can separate this into two fractions if you want to. You could write this as cotangent x over sine x times tangent x over sine x. You could leave sine x by itself, and you could just convert cotangent and tangent on top. That's what I did on the answer sheet, but I'm going to do this a little different way so you guys can see a little different view of it. So cotangent, I'm going to replace cotangent with cosine x over sine x, and that's over sine x, times tangent is sine x over, what guys? Cosine x, and that's also over sine x. Everybody see that? We have, I'll go back here like this, come here. So those were my things that I converted. Okay, So in my numerator, I see here that I can say, oh, well, if there's a cosine here and a cosine here, that crosses out. A sine here and a sine here, that crosses out. So I'm left with 1 on top, and my sine x is still, we're not multiplying that together. All I did was just split it apart so you guys could see it. But if you notice, this was over 1 of the same denominator. So this becomes 1 over sine of x. Now, if I look at my identity sheet, 1 over sine of x, that is pretty simplified, but I can write it where it's not a fraction, and that would become cosecant x. Well, guys, if you look over here, that's what we started with, cosecant x. So they're the same. All right, look at 50. 50 is a little different. Obviously, the left-hand side is a little more complicated than the right-hand side. So I'm going to focus on the left-hand side first. I don't have where it's a trig function, a Pythagorean identity, because it's not 1 plus cosecant squared. So I'm just going to go and I'm going to pull these apart. And I'm going to write this as 1 over secant theta plus cosecant theta over secant theta. We're allowed to do that. And then I have minus, and I'm going to change cotangent to our most basic functions, which are sines and cosines. So I'm going to say cosine theta over sine theta. Now we're going to sit here and go, oh my goodness, okay, what's the next step? What should I do now? Okay, so I'm going to simplify a little more, and I know that on my trig identities, that 1 over secant is the same as cosine, so I'm going to change this first fraction to cosine. And I can break down my cosecant and my secant a little more. So I'm going to rewrite this as cosecant is the same as 1 over sine. So I have 1 over sine theta. And then secant is the same thing as 1 over cosine theta. Remember, cosine and sine are our most basic trig functions, and we like to get back to there. So I would always try and convert to sines and cosines as much as possible. And I'm just going to leave my cosine and sine theta like it is. Okay, so we're going to leave our cosine theta over here, just hanging out. And I'm going to simplify this part. If I have 1 over sine theta divided by 1 over cosine, let's do a little side work over here. 1 over sine, we're going to keep change flip. So 1 over sine theta times cosine theta over 1 is just going to give me, when I complete that, that's going to become cosine theta over sine theta. Then I have minus cosine theta, over sine theta. Now, guys, think about this. Positive cosine theta and negative cosine theta. It's like saying positive 2 and a negative 2. Positive 7 and negative 7. They're going to cancel each other out. So I can just say this cancels out because a positive and a negative cancel each other out. I'm left with cosine theta, which is exactly what we were trying to get to. Now, not all the time does it work where you can just completely simplify one side and it equals the other side. But a lot of times that's what you should try and do. Simplify one side as much as possible, then move over to the other side. Okay, again, looking at this one, I don't have any Pythagorean identities. I don't have anything that has a fraction or anything. So I'm just going to go to my identity sheet and I'm going to simplify. Cosecant, remember our most simplified functions are sine and cosine. So I'm going to change cosecant to 1 over sine theta. And I'm going to multiply that by tangent is the same as sine theta over cosine theta. I'm going to leave secant alone because it's just chilling by itself here. Now when I multiply, guys, look, what happens to my sine thetas? They cancel out. I'm left with 1 over cosine theta. And as I simplify 1 over cosine, that's a fraction. So can I rewrite this trig function not as a fraction? Yes, 1 over cosine, if you look at your trig sheet, is the same as secant theta, which is exactly what we had over here. All right, I look at this next one and I think, oh my gosh, there's a lot going on. A lot of you guys will see that sine squared theta and you'll think, okay, should I go with sine squared theta plus cosine squared theta equals 1? That's a route you could go. But the first thing I do that I see is that both terms on the left-hand side have a sine theta. So what I'm going to do is I'm going to factor out a sine theta. So I'm going to take a sine theta out, and I'm going to be left with cosecant theta minus sine theta. We just divided that out and made it a little easier for us to look at. Now the second thing I'm going to do, I'm going to keep my sine theta out in front because we don't need to worry about it right now. So I have sine theta, and I'm going to change my cosecant. If I look at my identities, cosecant is the same as 1 over sine theta, right? And I have minus sine theta over 1. We're good to go there. We're good. Now I look in my inside my parenthesis, and I need to get a common denominator here. So a common denominator between sine of theta and 1 is going to be sine theta. So I'm going to write that my common denominator. So in the first fraction, I already have the sine theta, so I'm just going to write a 1. In the second fraction, I need to multiply the bottom by sine of theta. And when I do that, what I do to the bottom, I do to the top. So sine theta times sine theta becomes sine squared theta. Now when I do that, I see that I can now cross off my sine theta on the outside with the sine theta that is the denominator, which is perfect. Boom, boom. And I'm left with 1 minus sine squared theta. And on the right-hand side over here, I have cosine squared theta. Is there a Pythagorean identity that involves sine, cosine, and the number 1? And you guys would say, oh my gosh, we keep using this same identity all the time. You will use this identity a lot. Sine squared theta plus cosine squared theta equals 1. Well, if I want to make these two equivalent, I can either say, all right, I'm going to move my sine theta to the other side. And I get cosine squared theta. So you'll see here, you can either write this, you could actually just write an equal sign in between, but you could write this as 1 sine squared theta equals 1 sine squared theta if you change this side, or you could write cosine squared theta equals cosine squared theta if you wrote it on this side. Now this is different from the way that I did it on the answer sheet, just because I'm trying to show you guys that there's different ways to do these problems and you can still get the same answer. Some of you have been emailing me and saying, hey, this is the way I did it. Can I do it like this? Absolutely. Absolutely. As long as it makes mathematical sense, you guys are good. All right, I look at 55 and I see that I have two terms. I have a binomial in the denominator on the left-hand side and a monomial on the right-hand side. So what we've done previously, when we had just a binomial in the denominator that wasn't one of our Pythagorean trig identities because it's not squared, is we'd multiply by the conjugate. So the first thing I'm going to do is I'm just going to write down the conjugate of 1 minus, let's write this down, so sine x over 1 minus cosine x. The conjugate of 1 minus cosine x is going to be 1 plus cosine x. Whoops. So I'm going to multiply the top by 1 plus cosine x. So when I do that, I get sine x times 1 plus cosine x. You are welcome to distribute the sine x in there, but you're going to end up taking it out again, so I'm just going to write them stuck together. And then on the bottom here, I'm going to say, okay, I have to FOIL. When I FOIL, 1 times 1 is 1, 1 minus cosine x, and then I have cosine x times 1, so negative and positive cancel out. Then I have cosine times cosine gives me minus cosine squared x. When you guys will say, oh my gosh, it's the Pythagorean identity again. 1 minus cosine squared x, you guys can already say in your head, you should be able to say in your head, equals sine squared x. So I'm going to replace the bottom with sine squared x. So I have 1 plus cosine on top, and I have sine squared x on the bottom. You guys, everybody with me? And now I look at this, one more thing I can do is I can say, okay, on the bottom, I have, this is the same thing as writing sine x times sine x instead of this, and then I can cross one of my signs off. So I'm left with 1 plus cosine x over sine x. And you guys are like, wow, I don't know, can I do anything else here? Not really. Look at your identity sheet. There's not really anything else you can do. But if you look back up at the beginning, that is exactly what you were trying to get to. 1 over cosine x, sorry, 1 plus cosine x over sine x. There you go. All right, 48's a little difficult. I told you guys that in class. Obviously, the left-hand side is a little more difficult than the right-hand side. So I'm going to start on the left-hand side, and I'm just going to start to try and simplify and go to our most basic functions. So I'm going to rewrite cosecant. And cosecant, guys, if you look on your chart, cosecant is the same as 1 over sine. So I'm going to write this as 1 over sine x times cosecant, again, we just said was 1 over sine, so I'm going to write 1 over sine x. And then I have minus sine x over 1. I'm going to run out of room here. I'm going to have to go past the line, but you guys will see. And then I have, okay, then I'm going to take my sine x, I'm going to go over the line here, I don't have enough room, minus cosine x over sine x. And I'm going to change cotangent to what's our most basic function, sine and cosine. That's going to be cosine x over sine x. I think there should be a squared here on this one right here. Okay, so as we go through, again, I'm going to leave this out here for a second. Well, no, we can go ahead and distribute this. If I distribute this here and here, I have 1 over sine x times 1 over sine x gives me 1 over sine squared x. And then I have minus 1 over sine of x times sine x over 1 just gives me sine x over sine x, which is going to cross out and give us 1. We'll talk about that in a second. Plus, and then you notice, guys, look, these denominators are the same. So we can rewrite this whole thing on top with the same denominator. So this is the sine of x, and then our numerator would be sine of x minus cosine of x plus cosine x. So now, guys, if you notice, I can do a little bit of simplifying here. I have 1 over sine squared x minus sine x over sine x gives me negative 1. Now I look here and I say, okay, negative cosine and a positive cosine on top, those will cancel out. Then that leaves me with sine x on top and sine x on bottom, so those will cancel out, so I'm left with plus 1. Now I can look at this and I can say, oh wait, I can simplify a little more. I have 1 over sine squared x. What's negative 1 plus 1? They cross out, so I'm left with 1 over sine squared of x, which I can write that without a denominator, and that becomes cosecant squared x, which is what we started off with right here. So you have cosecant squared x equals. Now, remember, you got to square this. The 2 got knocked off somehow, I don't know. But guys, this is way shorter than the way that I did it on the answer key. Just trying to show you that there's a million different ways to do all of these problems.